Okay, in this section we're going to look at binomial distributions, and when we're looking at P, when P is 0.65 and N is 6, and we're going to find the probability of each of these. But let me explain what we're doing here first. So when we're looking in this section and the rest of this chapter, section 5.2 is specifically about binomial distribution. So this is what this homework is about. How do we know when it's a binomial? Well, first of all, you're going to have a number of trials, and that's going to be n. That's how many times you conduct the experiment, and each trial can only have two possible outcomes. Think of binomial like a bicycle has two wheels. Well, you can only have two outcomes with these. So the probability of it being a success is always going to be P, and the probability of it being a failure is going to be Q. And every trial is going to be independent of the other trials in the experiment. So here are some examples. Yes, I will, no, I will not. That would be a binomial distribution. It's a survey response, and there's only two outcomes. An electronic component is either defective or acceptable. Two outcomes, binomial. New job applicants either accept an offer or reject it. That's two, so it's binomial. Flipping a coin, heads or tails, that's two. So here is the formula, and we're going to take this formula and we're going to look at our problem. So when you're conducting a binomial distribution, you have all of these variables. So we have to figure those out first. So let's start with n. N is going to be your number of trials. So n equals, let's see what n is. Here, n is 6. Okay. And next is X, the number of successes. Let's see, for the first problem, we want to know when X is equal to 2. Okay, then we need to figure out the probability of success, which is usually given to you, and it is 0.65. How do you find Q? That's the probability of failure. Well, these have to add up to 1. So 1 minus 0.65 would get me to 0.35. So once you have those four values, you are ready to plug into your formula. So the probability that X is 2 and N is 6. So we're going to plug in N factorial, which would be 6, over n minus 2, which is 6 minus 2, and this part should look familiar to you. This is what part of this is what you did for combinations, that part. Now, P is 0.65, and then to the X would be 2, and then Q would be 0.35, and then n minus X, so 6 minus 2. Okay, so what we can do is kind of simplify this like I've showed you before. 6 times 5 times 4 over 4 and 2. And that way we can cancel this out. And I always want to try to simplify this part if I can. So 30 divided by 2 would be 15. So we're going to get 15 times 0.65 squared times 0.35 to the fourth. And I would just calculate all of that, put all of that into your calculator, and get your probability for this binomial distribution. Okay, when you put that in, you will get, when you round to 3 decimal places, 0.095. Okay, so well, 4 decimal places, so 0.0951. All right, let's look at the next part, and you have to be really careful here with all these calculations. We want the probability that x is less than or equal to 1. Well, to find the probability for x is less than or equal to 1, you have to find the probability that x equals 1 plus the probability that x equals 0. So we're going to use our formula. This information up here, most of it will stay the same, but first we want x to equal 1, and I think P was 0.65 and Q was 0.35. So we're going to plug into the formula for 1. So this time it's 1 comma 6, and in factorial it's still 6 factorial over 6 minus 1 this time, and 1. And then over here we're going to have 0.65 to the first and 0.35. N is 6 minus x is 1. So let's simplify this first. And 1 factorial is just 1 factorial, so that's really nothing. So we end up with 6. So we need to plug in 6 times 0.65 to the first, which is 0.65, times 0.35 to the fifth. And then once we get our answer, we're going to round it to 4 decimal places. And so when you plug that in, you will get, for 1, our probability is 0.0205. Now we need to do a 0. So this time we're going to put a 0 here and a 0 here. Everywhere I had an x, I'm going to put a 0. And this is really one of the easier ones, because watch what happens. 6 minus 0. Okay, so let me erase this. What happens is you end up with 6 over 6, 0 factorial. Well, that cancels out. 0 factorial is 1, so that's gone. And then 0.65 to the 0 power is 1. And then you end up with 0.35 to the 6. So really and truly, we just need to find 0.35 to the 6. And that would be 0.0018. So we need to add those together to get our probability that x is less than or equal to 1. So we will get 0.0223. And let's make sure that our rounding, we didn't have any rounding errors here, because it's very easy to do. Okay, so 0.0223 is correct, and they will allow a little bit of a tolerance here if you're off a little bit. Now, the probability that x is greater than 4. Well, x can only go up to 6. You have to know that in order to work it. So let's look at that, and I'm going to make this a little bit bigger so I can try to stay on the lines here. I'm going to make this smaller. Okay, so we have, if we want it to be greater than 4, it can only go up to 6, so that would be the probability that x is 5 plus the probability that x is equal to 6. So this is why this can be time consuming, because the formula takes time. So this time we're doing the probability that of 5 given that there are 6 in the sample. So n is still n over n minus x, and this time x is 5, and x again, and then you're going to have 0.65 to the x power, which is x is 5 this time, and 0.35 to the n minus x power. Okay, so I plugged in for 5. Now I just need to calculate this. So I'm going to do 6 times 5 factorial over 1 factorial, 5 factorial. So that cancels out, and you're left with 6 times 0.65 times to the 5th times 0.35 to the 6 minus 5, which is 1. Okay, so we will plug that into our calculator. Okay, so the probability of x equals 5, you will get 0.2437. Now I'm going to do the probability that x is equal to 6. So I am going to erase I'm just going to start from, it's easier just to start from the beginning. So n is still 6 over 6 minus x, which is 6, and then x is 6, and then p is 0.65 to the x, which is 6, times 0.35 to the n minus x, which is 6 minus 6. So these cancel, and 6 minus 6 is 0 factorial, which is 1. So 0.65 to the 6, let's see what that is. 0.0754. And we're going to add those together. .3191 is what you will get. So I know this is a lot of work. So take your time and make sure you just use the formula and work it out, and be careful to not make mistakes. Let me know if you have any questions.